Welcome to Scientific Notation. I'm Mr. Polarski and I'm going to be your host today. We're looking at this in terms of a pre-algebra topic, so let's get started. The human eye is fairly small and the retina is a small part of the eye. The retina measures 0.00013 meters thick. Now that's pretty small. Here's the crazy part. There is roughly 110 million rods and 6.5 million cones in the retina. Now, considering that how small this number is, 0.00013, and how big these two numbers are, it's pretty amazing that the eye has that many rods and cones in it, and considering that it is very, very tiny. So the rods and cones are also very, very tiny. To work with numbers this big and this small, we've come up with a scientific notation. Here's a definition of scientific notation. A number is written in scientific notation if it has the form c times 10 to the nth, where c is a number greater than or equal to 1 and less than 10. So it has to be greater than or equal to 1 and less than 10. Down here, some examples of using scientific notation. Here we have the standard form, and this should be 875,000. We see here the product form, 8.75 times 100,000, and then the scientific notation, 8.75 times 10 to the fifths. In this example here, we have 0.0003, or 3 10,000ths, 3.0 times 1 10,000th, or 0.0001, and we express that in scientific notation 3.0 times 10 to the negative fourth. We can see in this using scientific notation that from standard form to this product form, we put the decimal between the first two non-zero digits of the number, and we write it as a product of a power of 10, in this case 100,000. 7.5 times 100,000 would give us 875,000. From product form to scientific notation, we convert the 100,000 into a power of 10. That would be 10 to the fifth. Real easy way to figure that out. There are 1, 2, 3, 4, 5 zeros and 100,000, so that would be 10 to the fifth power. In the product form of 3 10,000ths, we have 3.0 times 1 10,000, 3.0 in scientific notation times 10 to the negative 4. It's negative 4 because there are 1, 2, 3, 4 places to the right of the decimal, therefore it would be 10 to the negative fourth. Using or writing numbers in scientific notation, from the example about the eye, there were roughly 110 million rods and 6,500,000 cones. Express those numbers in scientific notation. Well, here's the number 110 million. If we express that in product form, that would be 1.1 times 100 million. And in scientific notation, that would be 1.1 times 10 to the, now we just count the zeros, 1, 2, 3, 4, 5, 6, 7, 8, so times 10 to the 8. The other number, 6,500,000, we will first express that in the product form, which would be 6.5 times 1 million. And in scientific notation, it's 6.5 times 10 to the, and then we count the zeros in 1 million. 1, 2, 3, 4, 5, 6, so 10 to the sixth. So the two numbers expressed from the example about the eye and the retina and the rods and the cones, there are the number of rods expressed in scientific notation and the number of cones expressed in scientific notation. Talking about here the thickness of the retina, we have 0.00013. In terms of product, that would be 1.3 times 0.0001. And in terms of the scientific notation, that would be 1.3 times 10 to the negative fourth power. Next, we're going to look at writing some numbers in standard form. Here we have 3.25 times 10 to the 11th. The way to do this would be to write out the 3.25 and then using decimal moves. Since this is time 10 to the 11th, we need to move the decimal 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I like to put that decimal in. Then we just add the zeros that we need to add. Each valley or trough, if you will, gets a 0 in it. And if we move these troughs out of the way, we could go ahead and add in our commas starting at the right every 3 place values. And that looks to be 325 billion. 325 billion. And we can put the troughs back in if we want. The next number, 2.4 times 10 to the negative 8. Since it's a negative number, it's going to be a number that is smaller than 1. So we'll start with our 2.46. And we need to move the decimal 8 times to the left. 1, 2, 3, 4, 5, 6, 7, 8. That's where our decimal is going to go. Then we add the zeros. 1, 2, 3, 4, 5, 6, 7 zeros. Put our decimal place in, and we can move the troughs out of the way so we can get an idea what that number would look like. So we end up with a very, very small number, 0.0000000246 would be that number. Key thing I want to caution you about is that this is not just adding zeros. We did not just add 11 zeros to 3.25. We moved the decimal place 11 times. We did not just squeeze 8 zeros in between the decimal and the 2. We actually moved the decimal 8 times to the left. Another thing to be aware of is that if you have a positive exponent when working in scientific notation, that number will be a very large number in value, and if it's a negative number, it's going to be a very small number in value.